Hi, everybody. Good morning, and thank you for being here to share with us some time to practice and to have some ideas and some reviews about how to try to apply automation and artificial intelligence to our day-to-day and to our DevOps operations regarding application security. Okay. I'm going to show just a quick introduction with a couple of slides, and then I'm going to show the platform, our solutions, Ageni, in action, just to show some specific cases and use cases that I think are very close to our day-to-day. The main problem we have is that the number of alerts that we are reaching or we are gathering every day is increasing a lot. So last year, for example, we had like millions of leaked secrets. So most of them are even active in the repositories, and we didn't realize that they have been leaked and they are captured by bots or whatever. So we have in risk our infrastructure and our different environments. It's an important way of attacks. We have also a lot of different flows in our code applications. Okay, most of or more than half of our code has potential vulnerabilities due to lack of knowledge, lack of seniority, different reasons. Okay, so it's important also to detect these potential vulnerabilities and to protect against these ways of attack. The thing is, a vulnerability is not critical because it's a specific or it's a non-intentional attack, but we have to be prepared. And what is really important is the detection of malware or the malicious packages that last year we detect more than 500,000 of these packages. That is now or today the main way of attacking our application, because we are using 80% of our code is based on external source. So it's very important to detect these things. So we have more than enough different vulnerabilities and different risks. So the important thing is to find what is important for the security of our application and what is actually impacting on our security posture and what we have to do to improve the security posture with the minimum effort. At the end, if we apply automation with solutions like Ageni, for example, we are going to reduce the number of alerts that we have to manage from thousands or tens of thousands to just a few cents or hundreds. So we are going to reduce the task or the amount of work that we have to do. We are going to reduce a big amount of false positives that are not applying to our security, and we can discard it. We don't need to focus on or to take care on these things. And we are going to increase, we are going to have automatically the precision based on capabilities or attributes like reachability, exploitability of these vulnerabilities. So these are the important things that are affecting the security of our application. We are going to remove a lot of manual activity, doing analysis, triage, and these kind of things. And we are going to have an automatic way to create different funnels, smart funnels, that compose our prioritization criteria. So we are going to need just a few seconds to find what is important and what we have to solve. And finally, we support the developers' workflow, doing or providing these fixes in the code, in the configuration of our components, and these kind of things. Yeah, the idea is, or the goal is that according to our statistics or our experience, just between 10 and 20% of the alerts are really exploitable, and the rest is noise, and we can save a lot of time and a lot of effort from this point. For the demo, let's do just 3-4 important things. First of all, let's try to enforce or to force that all the pull requests that we do apply or doesn't contain malware, for example, and we can break the bill or stop the bill if we detect that something malicious is in the process of the integration or in our application. Then let's find the important things to solve regarding secrets, SCA, and SAST based on these smart funnels. And then let's do some fixes regarding secrets. We are going to create or revoke these secrets automatically, and then let's review or correct some vulnerabilities in the software composition analysis and the code flow. Okay. For that, we have created a small application okay, that we have is a JavaScript application containing different things. And we have also built or created several workflows. One for build the, the application that we are going to generate a WAR file. We are going to have this artifact in the repository. And we have these configuration stages, the Maven build. And then we have our scanner here configured to stop the build if we detect malware, okay? These URL or these policies are configured using these languages or these configuration files. I have a couple of them here, one for detecting secrets and one for detecting malware component. So if we detect something malicious, we are going to stop the build and we are going to exit with the code 160, for example. You can configure as you want if you want. And then we have different sets of vulnerabilities. We have our local analysis, our plugin for detecting things, and we have here a couple of injections through the application. We have some vulnerabilities in the components, and we have also some secrets that we have put here. We have 3 secrets here actually. 2 of them are valid secrets that we are going to show in the GitLab. One is inside the comment, but is equally valid. And we have someone that is invalid because it has been revoked. So we don't have to do anything with that. It's not a risk, actually. And we have something that is very similar to a secret, but actually it doesn't comply with the form, and it's not a valid secret, okay? So taking these things, first of all, what we are going to do is let's try to build this artifact that we have prepared using this part. And we are going to see how everything goes and try to build the artifact and to prepare everything. And then how we break the build part, okay? So if we review the different logs, we are seeing how the build, the compilation, integration, and all the things. Okay. It takes some seconds. We are going to start the scanning part. We are going to do all the discovery of the components, the resolution of the 3 dependencies. We are going to find all the secrets, the vulnerabilities, and these things that we are going to put in the platform just to do the later analysis. And at the end, we are going to see the message showing that the artifact was not created, or we can stop the process with these capabilities. These are the secrets that we have mentioned or we have seen before. Okay. It's almost finished. And we have here the message, okay, showing that, okay, we have detected something in the dependency part that is breaking or is compliant with the URL's conditions, and we are breaking everything and exiting from this part, okay? So at the end, we are not having here the artifact created. If we switch to the platform, okay, we have here couple of secrets. This is our interface, and we have here a demo, and this is our project. We have marked, or we have flagged with the malware that we have detected, and we have some issues and some summary. If we start the drill down to analyze the content, we see, okay, that we have all risk view, that we have detected all the SAST, SCA, secrets, and everything. We have here the malware and the different issues. And the important thing is that, okay, we start seeing here some prioritization and some important things. First of all, well, I'm using this simplified funnel, okay, for the demo, but you can use any demo you want, any funnel you want, sorry, and you can configure your own prioritization criteria. You have more stages or less or different values. The thing is that, okay, we are putting focus on things that are reachable and are exploitable, that are the important things. We can switch. Our goal is to resolve or to fix all the exploitable things with critical and high criteria, that are the important things, okay? For this, we can start reviewing. If we go to the secrets part, we can see a funnel, a bit different because some stages doesn't make sense in this part. And we have these 3 secrets that we have detected. Only 2 are exploitable because one of them is inactive, as we mentioned before, okay? And we can see these secrets are these 2 ones, okay? This valid and valid one that was in the code, and the invalid is something that has invalidated in the past. If we launch this workflow that actually invoke our scanner with the remediation flag, okay, we are going to see how automatically we revoke all these active secrets in the environment. We are using GitLab because it's easy to see the secrets, but you have near 30, almost 40 different systems configured out of the box. So you can revoke secrets from Slack, from GitLab, from a lot of AWS and a lot of different systems, okay? Sorry. So here we are running everything. Okay. We are running the secrets with auto remediation enabled, and we are going to revoke these secrets. So we have detected these ones, we have solved them, and if we go here and we reload, okay, we see that the 2 secrets that we have here has been invalidated. Okay, so first step done and solved. If we switch to the software composition analysis, we have similar approach. In this thing, we have all the vulnerabilities in our applications, but the important thing is that only 21 are reachable. This means that most of the vulnerabilities, almost 60% of them, are not reaching or our application is not reaching the vulnerable part of the component. So we don't have to solve it because it's not affecting our solution. We can live with it. The focus is we have to solve this to be completely secure. The next step is, okay, could be a number quite high in some cases, so the focus is the exploitable one. The exploitable one is the set of vulnerabilities that are the focus of the attackers because they are putting or they are focusing on things that are easy to exploit. Okay, so this is the urgent things to solve. For this, we are going to select all of them. We are going to launch bulk remediation. We can remediate automatically some of them, and we have to remove manually the malicious component in this case. We are going to create just one pull request to modify the configuration. Okay, everything is done, and we are going to remove from this part, we are going to remove the malware component that is here. We are going to remove this part. We are going to remove this, and we are going to remove okay. So we update everything. So we have removed the malware manually, and we have created a pull request to solve the rest of one. And if we switch to the SAST part, we have each of this vulnerability. 3 of them are critical, okay, regarding some configurations and some parts. In this case, we have to apply artificial intelligence because we don't have this rule set for do the version bumping or this kind of strategies. So we are downloading the code. We are applying some models to identify the intention of our code, and we are replacing or proposing the changes through pull requests, also with some explanation for the developer. We are going to create the different pull requests. We are going to try to solve all these critical things that we have. Okay. This one. And the latest. Sorry. Okay. And now, once we have everything solved, we are going to put everything together, and we are going to rescan. So we should see in the funnel that we have solved everything and we have removed all these critical exploitable things in the application. Okay, so we create the pull request. Okay, so if we go to the code, we see the pull request, and we have here the changes for the version bumping of the dependencies. Okay, let's do the merge. Let's do the same for the other remediations. And the last one. Okay, so we have everything prepared. We have everything processed. So now let's try to build again the artifact and to see if now everything is okay and the risk has been removed. What's happening? Sorry. Well, let's scan from here. I don't find the issue. We are scanning now, and when it finishes, we are going to have the results in the platform. We still detect the secrets, but actually they are inactive in all cases, so they are not exploitable. We are reducing the risks. Okay, finished. We receive the report we are processing. We come from increasing the risk in the project. We should see now how we are decreasing the risks in the same project, in the application. The integration, I click here because we have integrated the repositories also from this part, and we can see all the activity in the repository for all the repositories in the software code management system. Okay, so we have everything. The processing is calculating this context information to ensure that everything is properly solved and resolved. So well, if not, while it finishes okay, just now, if we switch to this part. Okay, we have seen, or we see that we have removed all the critical and high issues here. We have removed all the secrets. Okay, none of them are exploitable. From the software composition analysis, we have removed all the exploitable vulnerabilities also, and we have removed also all the vulnerabilities that are critical in the application. So this is the experience. So at the end, we have removed, as prepared or as planned, all the critical and high vulnerabilities that are exploitable, that are urgent before going to production in just a few minutes. So next steps after this, we have done this very quickly and manually. The idea is, okay, instead of having the build workflow only to launch manually, enable to monitor every pull request, okay, so you can continually scan and analyze everything. And to apply these AutoFixes automatically also, you should enable the bot from Cyeni and decide what type of vulnerabilities you want the bot solve continually, so the developers can find the pull requests in the repository just to review and approve them. That's all. If you need or want more information or whatever, you can visit in our booth. Thank you very much.